So let's talk about integrating something like cosine squared of x dx. We can't use u sub because if we think of this as cosine of x all squared, our inside function would be u is cosine of x, and du would be negative sine of x dx, and we don't have a sign on the outside. So u substitution wouldn't work. But what's nice is this is a trig function, cosine squared, and we have a lot of trigonometric identities. So we're going to use trig identities to solve this and try to rewrite cosine squared of x into something that we can find an antiderivative for. So one trig identity you hopefully remember is sine squared x plus cosine squared x. This always equals 1, and that's because sine and cosine are coordinates on a unit circle, and when you square and add them, you get 1. Now, maybe a trig identity that you don't remember off the top of your head is the double angle formula. And that's what you can do with something like cosine of 2x. So cosine of 2x is cosine squared of x minus sine squared of x. And this one, combined with the trig identity that we know, sine squared x plus cosine squared x equals 1, will give us a way to replace this cosine squared with something we can integrate. So let's put these together. Sine squared x must be equal to 1 minus cosine squared x from our trig identity above. And that means I can rewrite my double angle identity as cosine squared of 2x minus that 1 minus cosine squared x. But if I subtract the negative, I get a plus. Which means that cosine of 2x is actually 2 cosine squared of x minus 1. And now I can solve for cosine squared of x. So I'm going to add 1 to both sides, and then divide both sides by 2, or multiply both sides by 1/2. And now I can rewrite my integral the integral of cosine squared of x is equal to the integral of 1/2 cosine of 2x plus 1/2 dx. Often it's written instead in 1/2 plus 1/2 cosine of 2x. And people often skip to just this trig identity that cosine squared of x is 1/2 plus 1/2 cosine 2x. And now we can find antiderivatives. So an antiderivative of 1/2 is 1/2 x. A simple u substitution will give me 1/4 sine of 2x, and then there'll be a plus c. Similarly, I can find the integral of sine squared of x using trig identities that are actually the same two trig identities. So if I wanted to find the integral of sine squared of x, I could use the same two trig identities. I'll use sine squared of x plus cosine of squared of x is equal to 1. And I'll also use cosine of 2x is equal to cosine squared of x minus sine squared of x. Only this time I'll replace the cosine here with 1 minus sine squared of x using star. So now cosine of 2x is the same as 1 minus sine squared of x minus a second sine squared of x. So that's 1 minus 2 sine squared of x. And this time I will solve for sine squared of x so that I can replace it in my integral. So I'll subtract 1 from both sides. I will multiply everything by negative 1/2. And now I can rewrite my integral using this trig identity. So the integral of sine squared of x dx is equal to the integral of 1/2 minus 1/2 cosine of 2x. And I can find an antiderivative just like before. A simple u substitution will give me negative 1/4 sine of 2x. Of course, an antiderivative of 1/2 is 1/2 x, and I don't want to forget to add the plus c. Notice that these are very similar for these two functions. For cosine squared, I replace with 1/2 plus 1/2 cosine of 2x. For sine squared, I replace with 1/2 minus 1/2 cosine of 2x. And I just use trigonometric identities to make this replacement, so I can now find antiderivatives.